Hello, and thank you for joining the webinar today. We're going to give folks another minute to log in, and we'll be getting started soon. All right, let's get started. Hello, everyone, and welcome to the 2023 to 2024 Better Buildings webinar series, dedicated to bringing you the latest actionable insights from leading industry experts. This annual series is a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate decarbonization and energy efficiency adoption. And next slide, please. Today's webinar is called The New Cool, the Transition to Low GWP and Natural Refrigerants. Before we dive in, there are a few housekeeping points I'd like to cover. Please note that today's webinar will be recorded and archived on the Better Buildings Solution Center. We'll follow up when today's recording and slides are made available. Next, all attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message to the Q&A box located on the bottom of your Zoom panel. All right, and next slide to introduce myself. My name is Sarah Stubbs. I'm an ORISE Fellow with the Department of Energy's Building Technologies Office, and I will be your moderator today. And next slide, please. So for today's agenda, in a minute, we're going to do some polls. We're going to learn about who's on the line, who's attending, and what you especially want to learn about today. So hear from our audience. We have 3 great speaker presentations. And then at the end, we're going to have some time for open Q&A from the audience. Next slide, please. So today for our polls, we're going to be using an interactive platform for Q&A and polling. Please go to www.slido.com, SLIDO.com on your mobile device or by opening a new window in your internet browser. Today's event code is #DOE or #DOE. If you would like to ask our panelists questions, please submit them anytime throughout the presentation. We will be answering your questions near the end of the webinar. You can select the thumbs up icon for questions that you like that someone else submitted, which will result in the most popular questions moving to the top of the queue. All right, so on to our polls. So we want to learn about you, who's on the line. So let's start off with a few polls. So please join us over at Slido. Again, that's SLIDO.com to respond to the following questions. If you're having any issues, please message our tech support team by using the Zoom Q&A function. So starting off, what sector best describes your organization? We have a lot of contractors or consultants. I see a fair amount of state government on the line, local government, giving them a run for their money. Seeing lots of industrial folks, and nonprofits and NGOs. Some commercial real estate, higher ed, food service and grocery. Overall, we have what looks like a great group joining us today. So why don't we check out the next poll? So what is your experience with low GWP and natural refrigerants so far? So answering this question is really helpful for our panelists as they give their remarks, and they're going to be able to sort of address their remarks to who's on the line. So we have a lot of folks who are saying, what's the big deal? Tell me all about this. We have a lot of folks whose organizations are considering low GWP HVAC systems, and then somewhat fewer people whose organizations are considering low GWP refrigeration systems. And then we have a contingent of people whose organizations already use these low GWP refrigerants. So awesome to see it. It looks like a great mix of experience that we have here. I think we can go on to the next poll. So what low GWP or natural refrigerants are you most interested in? And of course, so this is a write-in. You can write in what you want. And you can also, I believe you can also upvote some of the other answers that are coming in. So we're seeing a lot of CO2 folks, propane, R290. And of course, refrigerants have both that technical option like R290 or categories like A2Ls. And then you also have the more common names such as propane. People are looking for energy efficient and cost-effective options. A lot of folks saying they're interested in what goes in HVAC systems. And I promise our panelists are going to address a lot of this stuff. So you can learn what GWP is, you can learn the difference between CO2, ammonia, that kind of thing. HFOs, propane, some folks are not sure. And I've seen a lot of answers about, we want to know what the major manufacturers are going to be embracing, which is a great point. With some folks just saying, I need to know what the options are. Well, we're going to talk about what the options are today. The substitutes, maybe that are drop into your existing systems. A lot of CO2, a lot of HVAC. And what could be combined with HFC refrigerant replacement? Some ammonia. We are going to talk about ammonia today. And which ones are best? How do we know which ones to use? What are the pros and cons? So these are some great answers, and I'm so excited to get into talking about this. So thank you so much. And why don't we go on to the next poll? So what, if anything, do you find concerning or confusing about low GWP and natural refrigerants? So we just want to open this up. I know there are a lot of questions. A lot of folks are feeling like they need to learn about the basics here. We are going to talk about the basics. So what do you want to learn today? What are you worried about? What is not clear for you? So we're seeing some stuff about state policy, how they're being adopted, upskilling technicians. Flammability is a major problem. I also saw safety and leaks, information on pricing, more regulations. Regulations are a huge question here. We're definitely going to talk about today. So what's available for a commercial HVAC system? What's the impact? What fits with the green movement is a great question. Drop-in replacements, that's a great point as well. More information about toxic and flammable alternatives and the safety for them. Let's go concerns about A2L regulations and PFAS. Lots of concerns about regulatory requirements. We're absolutely going to talk about that. And what are the benefits? And I've seen a lot of comments about leaks as well. So what are the major obstacles? And how do you know when they're compatible, how long they last, reliability, performance? There's a lot to think about here, and we're going to address a lot of this. So thank you all so much. Why don't we go on to our next question? All right, so we've covered a lot in the last question. I think if there's anything you haven't gotten to say yet, is there anything else you haven't gotten to say yet that you hope to learn about today? And remember, some of this is going to be addressed by the panelists, and this is also a great opportunity to ask the panelists to talk about something as well. So how to reduce CO2 emissions, what are industry trends and best practices? Phase out timing, we'll absolutely be talking about that. How do you compare your alternatives? Future GWP limits and good practices. What's coming and what's available now? That's a great question. What are the costs? Absolutely. some safety issues by refrigerant. We're going to talk about that a little bit. Market readiness. A lot of questions I'm seeing about installation details as well. And maintenance for efficiency. We're going to get into that to a certain extent. Kind of a lot of questions about sort of what is trending and what's coming. And of course, more questions about regulation as well, which is very understandable. All right, this is so helpful. Thank you all so much for participating. And we're going to continue to have opportunities to participate by submitting questions through Slido, through that link in the chat. I think for now, we can go on to our next slide today. All right, we have a great lineup of presenters today. We have Michael DeRue from the National Renewable Energy Laboratory, Morgan Smith from the North American Sustainable Refrigeration Council, and Mark Minter from AgriPure. So thank you all for being with us today. I think we're going to go on to the next slide and introing our first speaker. So Michael DeRue is the group manager for the Advanced Buildings Equipment Research Group at the National Renewable Energy Laboratory. With over 25 years of experience, he has conducted a broad range of research in commercial buildings, including building performance simulations, development and validation of energy efficiency technologies, publishing source energy and emissions factors, water, and the U.S. Life Cycle Inventory database. He has authored or co-authored over 100 technical reports and peer-reviewed publications and received an R&D 100 award in 2005. And with that, I will hand it off to Michael to kick us off.
Great. Thank you, Sarah. And thank you all for joining today. Very excited to be speaking with you and sharing some information about refrigerants. Go to the next slide, please. Actually, go to the next one. So really, I want to start out, why do we care about refrigerants and HFC refrigerants in particular? This is an estimate from the World Meteorological Organization that if we have this global phase down of HFCs, that we could avoid almost a half a degree Celsius warming by 2100. That's a very significant impact. And this is why people are very concerned about refrigerants, because they do have high global warming potentials, and their use is pretty ubiquitous. So we want to try to manage that. So go to the next slide. And let's back up a little bit. In 1970, the US passed the Clean Air Act and provided the EPA with regulatory authority for some of the refrigerants that we're using. At that time, we were trying to phase out the HFCs because of the ozone depletion. And Section 608 provides regulatory requirements for handling of refrigerants in stationary air conditioning. Go to the next slide. And then 612, EPA provides the Significant New Alternatives Policy, or SNAP. They publish the allowable refrigerants that can be used. So as they phase out refrigerants, SNAP provides the refrigerants that can be used as in replace of the old ones. And we've gone through these phases of going through different refrigerants because they work great, but then they have side effects. And so the first ones that we used very early on had toxicity issues and were not, performance was not great. And then in the 1930s, they started introducing some really great refrigerants like R11, R12, R22, but those had high ozone depleting potentials. So we phased those out, and then we introduce HFCs, which have a high global warming potential, and now we're phasing those out. So we're in this cycle. So hopefully we can avoid doing that again. But go to the next slide, please. And then the AIM Act, or the American Innovation and Manufacturing Act of 2020, introduced a phase down schedule for these HFCs or hydrofluorocarbon refrigerants that are widely used today. This is a pretty significant phase down. It's not a complete phase out. It is a phase down, and it is weighted by the GWP. So we're targeting the highest GWP HFCs first, and then we continue down to where we're down to 15% of our 2013 average, 2011 to 2013 average. So the AIM Act does three things. It introduces this phase down schedule. It introduces some technology specific restrictions for this transition, and it allows EPA to implement regulations that control reclamation and minimize releases from equipment. One thing it does not do is does not impact existing systems directly. So you do not have to go out and change HFCs in your existing system. So if you have a whole fleet of HVAC systems using R410A or others, you can continue to use those systems. The challenge is that in the future, in 10 years from now or so, that I don't know what the cost of that 410A is for recharging those systems. So if you need to recharge those systems, that 410A or whatever you're using could be more expensive. That is still to be determined. We don't know what's going to happen there. All right, go to the next slide, please. So the sector-specific regulations, EPA just released these guidelines at the end of 2023 that residential and light commercial HVAC, there will be a restriction starting January 1st, 2025, that they have to use, there's a GWP limit of 700. So 410A, which is the most commonly used refrigerant in those systems, will no longer be allowed. And you'll have to use things like R32, R454B, or some naturals or some other refrigerant. There's an asterisk there that equipment that is manufactured prior to January 20, so manufactured this year, basically in 2024, they will still be allowed to sell those up through January or through 2025. So January 2026, there will be no 410A or other high GWP equipment. And then you can see these other restrictions. There may be changes. This is brand new, and so there's often revisions to some of these rules, but just stay tuned and we will see what happens here. Go to the next slide. So then the last part of the AIM Act was managing the use and reuse of HFCs. So this is a brand new proposed rule published in October 2023. That means it's still out for public comment, but basically EPA says you will have to do leak repair on systems with more than 15 pounds of refrigerants. So that's a pretty small system. And then you should have automatic leak detection for any systems with over 1,500 pounds of refrigerants. This is the next bullet saying you have to use reclaimed refrigerants for new installation and servicing of existing equipment after January 1st, 2028. So all the after January 1st, 2028, that could drive up the cost of those R410A and other refrigerants that we're using today. I don't know what'll happen. There will be a lot of reclaimed refrigerants that will be available to use, but may not meet the full market demand. We don't know yet. And then there's some regulations around the cylinders and containers of HFCs. Again, all of these are proposed and they may change. We'll just have to wait and see when the final rule comes out. Next slide, please. All right, so on top of the AIM Act and the federal regulations, there's state HFC regulations, as many of you know. The US climatealliance.org is one place where you, these states, there's 25 states that are a member of this climate alliance. There's 11 states that have HFC rules. Some of them are different than the federal rules. So you'll need to go and see if you operate in those states, what those rules are. So, and some of those have recently changed. So you'll need to go and see what those are. I can't keep track of them all myself. So I don't know what they are to tell you that. But let's go to the next slide. One thing that we do need to be concerned about is refrigerant safety. So some of these new refrigerants or alternative refrigerants that we're considering have either higher toxicity or higher flammability than what we're often used today. So ASHRAE Standard 15 defines these categories of safety. So there's A1, it means that there's no flame propagation, low toxicity. And then a lot of the ones that we are considering using in this first effort, like R32 and R454B, are considered A2L refrigerants. They have that means they have a low flammability. And there's certain safety concerns around that. And then the high flammability, like propane and isobutane, that I saw people were looking at, those we know have high flammability because we use them for cooking and other things. So, but those there's certainly safety precautions around those. And right now there's very low charge limits on those. Another refrigerant that is commonly used, a natural refrigerant today, CO2 is A1. It has no toxicity and no flame propagation. But another one is ammonia. It is a B2L because it is highly toxic and does have a potential for flammability, but it's a low flammability. Next slide, please. All right, so here are some of the refrigerants today for HVAC package units like rooftop units and chillers. So oftentimes today for rooftop units, we see there's still a lot of R22 in circulation today. Nothing is sold, it's all old existing systems. R410A dominates those systems. What they're looking at for refrigerants in the next couple years or year is R32 and R454B are the two most common refrigerants. And you can see the 100-year global warming potentials. Those are what we use for regulations. So both R32 and R454 qualify under the AIM Act. They're both lower than 700 GWP. For chillers, there's some better options, I think, for low GWP refrigerants. The R513A is one, and then the R1233ZD and the 1234ZE. Those are both considered HFO refrigerants. Challenge with some HFO refrigerants, not all of them, is that they do contain the PFAS chemicals, some of them, which are the forever chemicals. So that is a concern that we want to be careful about. Next slide. Just wanted to put out some natural refrigerants. You'll hear a lot more about these in the next two presentations, but CO2, propane, and ammonia are, and isobutane, I didn't put on here, R600. Those are the most common natural refrigerants we use today. They work really well as refrigerants, but they do have some challenges that we need to learn how to manage. And you'll learn more about that in the next two presentations. All right, next slide. Almost finished here. So this is just some resources that are available from the EPA if you want to learn more about the regulations, and then California SNAP because they're a leader in this area. And then NREL just recently published this HFC phase down fact sheet. Last year, there's English and Spanish versions available. The link that I share here is for the English version, but you can also search for the Spanish version very easily. Some of the things that I talked about today from these latest regulations from the EPA are not in that fact sheet because they are very new in the last few months. But everything else that I've talked about is in there today. And I believe that is my last slide, one more, and then thank you all for your coming today and listening. And we'll look forward to answering any questions later.
Thank you so much, Michael. And now we're going to go on to the next slide so we can hear from Morgan Smith. Morgan is the Program and Communications Director at the North American Sustainable Refrigeration Council, or NASRC. She has a background in sustainability, communications, and project management, with a particular interest in aligning business goals with sustainability solutions. Prior to her role at NASRC, she managed forest management programs for landowners at the American Forest Foundation. And Morgan, the floor is yours.
Thank you so much, Sarah. If you want to go to the next slide. So just a quick step back, a little bit about NASRC and why I'm here talking about this today. We're a 501c3 nonprofit. We work in partnership with the supermarket refrigeration industry to address some of those barriers that Michael was talking about to natural refrigerants. We were founded about 8 years ago by stakeholders from the supermarket industry who saw a need for an organization focused specifically on CO2, propane, and ammonia, primarily because those refrigerants can't be patented. And as a result, there's not a natural champion to address some of those challenges and make them, a strong business choice. We've grown quite a bit since that time. We work now with over 160 organizations across the industry and focus together on building a sustainable technician workforce, increasing funding support for natural refrigerant options, and improving education and technology optimization. I'll talk more about how all of that applies here, but really all of this has become much more important and urgent amidst all of the regulatory pressures that Michael just spoke about. So next slide. I want to acknowledge that this is not the first time the industry has gone through something like this. It started back with CFCs and HCFCs, which, as Michael acknowledged, were phased out because of their ozone depleting characteristics. And that was through the Montreal Protocol at the international level, which took us to the refrigerants that we commonly use today, HFC refrigerants like 404A or 507A. They came into use as alternatives to those ozone depleting refrigerants. Unfortunately, we then learned that we effectively replaced one environmental catastrophe with another when we learned that these refrigerants have extremely high global warming potentials, which is really bad news for the industry because that means yet another refrigerant transition. HFCs are a drop-in solution to CFCs, and what that means is they don't require a full system replacement. So that's a much more cost-effective way to do the transition. But of course, they are now on their way out through international, federal, and state level regulations. So where do we go from here? There's a few different directions the industry is taking. So the next class of refrigerants is what we call HFO blends. These are a blend between HFC refrigerants and then the newest class of refrigerant, HFOs or hydrofluorolefins. This category is very broad, and so not all of these characteristics on this slide are exactly right. Some of these blends are pretty easy to retrofit and you continue to use existing equipment and systems. So refrigerants like 448 and 449, you can do a gas change out with just a few component changes. Some of these are less so and still require quite a bit of equipment replacement. The biggest implication here, and Michael brought this up as well, is that the HFO portion of these refrigerants are at risk of being classified as PFAS. For those who are not following this issue, PFAS is a class of chemicals, sometimes called forever chemicals. There's a lot of concerns around their impacts to public health and human health. And in Europe, many HFO refrigerants have been classified as PFAS, which puts them at risk of, future regulation and restrictions. That has not happened yet in the US, but we are starting to see a number of proposals at the state level. So it's just something to be aware of, something we're keeping an eye on. So that brings me to the next class of refrigerant, pure HFOs. These are much lower GWP alternatives, in many cases less than 10. Again, they have that concern about PFAS, but they are not subject to the new HFC regulations that Michael just reviewed. And they are not a drop-in solution. And then finally, we have natural refrigerants, such as CO2, propane, and ammonia. They are non-ozone depleting, ultra low GWP, exempt from regulations, not at risk of being classified as PFAS. They're market ready, but the challenge again here is that they are not a drop-in solution. So there's no, silver bullet. I've heard many times from Tristram Coffin and other folks in the industry. The industry is in a difficult position and needs some solutions to navigate this transition. Next slide. So this is really just to show the massive gulf we have in the GWP difference. So the GWP, global warming potential, it's really the potency of a greenhouse gas, how much heat it traps in the atmosphere. So you've got the high GWP HFCs at the bottom here, those HFC, HFO blends in the middle, the retrofittable ones, and then natural refrigerants at the top. You can see this is a very big difference. And one of the reasons that natural refrigerants are highly regarded as, the most climate-friendly and future-proof option. Next slide. And I just want to acknowledge that while regulations are a major driver here, they're not the only driver. Corporate climate commitments have risen significantly in the last few years, and I think more and more businesses are starting to realize that it's not possible to achieve those climate targets without addressing refrigerants. And at the same time, as awareness of the impacts of HFC grows, there's an increasing public pressure on businesses. So this is just an example of a campaign that Green America ran recently to target Kroger, putting a lot of pressure on them. Next slide. So all of this stacks up to a significant increase in the demand for natural refrigerants. This graph is based on a survey that we did last year where we surveyed 13 major food retailer companies that represented over 18,000 US store locations. We looked not only at the number of CO2 stores that they currently have installed, but also how much we expect that to grow over the next 5 years. And you can see here that the projections were over 300% growth by 2027. And the majority of that growth is actually from remodels, which is significant because, again, because these refrigerants are not drop-in, that means there's a pretty costly and challenging full system replacement required. But a number of retailers are seeing, the writing on the wall that this is going to get them out of this cycle of transitions. So we are planning to redo this survey this year and expand to include other refrigerants and really get a better idea of where the industry is headed. So you can expect to see some updated data released by us later this year. Next slide. So despite, there's a rising demand, the industry is certainly in a transition already, but there's still a number of barriers that need to be addressed before, the food retail industry and really the refrigeration industry can make this transition on a widespread basis. So there's 4 areas where NASRC works. This is kind of our theory of change. And this first one is well underway. Now, as demonstrated by that last slide, there's already a rise in demand, but there's definitely an ongoing need for knowledge and information sharing across the industry so that we can move forward together, share lessons learned. A rising tide lifts all boats. But then the second is to advance funding support. There's a real need here to offset the cost of these projects, especially for smaller businesses and especially for existing facility remodels. The third need here is to optimize technology options. This can be done through education, technical guidance, updates to codes and standards, performance studies. All of these things are needed. And then finally, last but definitely not least, is workforce development. to build up our technician workforce and make sure everybody's trained and ready to install and service these technologies. So in the next slide, I'll talk a little bit about funding. You know, our vision for funding has always been to pull together as many funding sources as possible to support these projects. And so this is really to help offset that high price tag when you're doing particularly an existing facility replacement or remodel. We've worked on a number of funding sources over the years. It's an exciting time in the industry because we're starting to see more of these funding sources come to fruition right now. So starting with state funding, it really all started here in California when they allocated $1 million to their F-gas reduction incentive program in 2020. That program has now grown to $65 million, which is really exciting. I'll talk more about that in a second. But I would say of equal importance, that program provided a model for other states to follow. And we've already seen other states taking steps towards that, expressing an interest in this. And so that's something that we're continuing to push for. Carbon financing, you know, we did a small pilot a few years ago to try to get this market off the ground, passed it over to our partner Therm Solutions, who took it, ran with it. They now have, I think, over 1,000 projects under development. This is a great option for smaller businesses. They get revenue for the sale of carbon offset credits gained from these projects. And so it's a great option for smaller businesses that don't necessarily need to claim those credits, but don't necessarily have the capital to invest in these types of projects. Less appealing to some of the smaller or the larger chains and larger businesses because sometimes claiming those credits is more valuable than the revenue. And then lastly, utility incentives. Of course, this is for energy efficiency, but also there's a big push right now to try to incorporate refrigerant GWP into utility incentive metrics so that businesses could get incentives not only for the energy savings, but also for the emission savings. Next slide. And so for the FRIP program, California, this is a really big opportunity coming up for the industry. We're the third-party administrator for this program, so we're working on it actively right now. $65 million will be available. The goals of the program are to accelerate the replacement of HFC equipment with refrigerants below 10 GWP, to prioritize disadvantaged communities and small businesses, and focus on direct refrigerant emission savings. So not energy savings, which is great because that gives us an opportunity to stack with other incentives for energy savings. In terms of timeline, we're currently developing the funding guidelines in partnership with the California Air Resources Board. So we'll be announcing some opportunities for public input in the near future, and we hope to launch the program in Q2. So stay tuned for more updates there. Next slide. So, you know, even if we have all the funding in the world, the market is ready, businesses are ready. We do have a major challenge in front of us. We really don't have enough technicians to do this work. We are facing a critical shortage of technicians, and at this time when the industry is doing this transition, we need to build that up. Our workforce is retiring out. There's not enough new technicians entering the field. It's really putting a lot of strain and pressure on our existing technicians, which is causing this burnout loop and exacerbating the issue even further. Next slide. And so we see that the way we have to do this, we have to come together as an industry to focus on 3 key areas in tandem. Recruitment, bringing more technicians into the industry. That's, you know, much broader, looking at HVACR programs, but also much broader than that. Training, providing training on the basics of refrigeration, but also on natural refrigerants and other advanced refrigeration technologies, and retention, making sure we're not losing the technicians we already have. Next slide. So very quickly, I'll just acknowledge we've got a number of natural refrigerant training summits that we're hosting this year. These are free 3-day events where we send 300-ish technicians to one place to get access training from all of the different manufacturers and industry experts all in one place. So we've got a few coming up in Pittsburgh in March, Irwindale in April, and Seattle in November. If you're interested or if you know any technicians, please feel free to forward this to them. It's a great opportunity to learn. Next slide. And I think that's it. Thank you so much.
Wonderful. Thank you so much, Morgan. And I think we can go on to the next slide. So a quick reminder to our audience for the very end to send in any questions you have at www.slido.com. That's SLIDO.com with the event code #DOE. We look forward to answering your questions at the end of the session. But first, we're going to hear from our final speaker, Mark Minter. Mark is an energy engineer for Agripure, one of the world's top 20 dairy producers. For the past 10 years, Mark has been the engine behind most of Agripure's award-winning energy efficiency projects across all U.S. manufacturing facilities. Recently, Agripure has committed to reducing its greenhouse gas emissions by 30% by 2031, with the goal of achieving net zero emissions by 2050. Mark worked closely with the emissions reduction target setting team to make sure these numbers were grounded in operational reality. Mark, take it away.
All right, thank you, Sarah. Next slide. Yes, Mark Minter here, energy engineer from Agripure, here to talk about really our ammonia system. So you can go to the next slide. As you said, we are a very large dairy manufacturer. That's why we need lots of ammonia. We use ammonia for the majority of our refrigeration systems. Certainly in manufacturing is all ammonia. We do have some other refrigerants, maybe in office areas that are different, but we make just large quantities of cheese. So, 400, 500-pound barrels of cheese and whey proteins, and it takes a lot of cooling to do that. So, next slide. So where do we use our ammonia? Well, we use it in silo cooling. So the milk, all of our cheese starts out as milk. It comes in, we put it in these silos. They have to maintain the right temperatures in summertime. It can get quite warm. So these are jacketed with insulation, but we certainly do provide cooling to these. And that gets used a lot more in the summer, but certainly an area that we definitely need cooling. Next slide, please. We also have a chilled water loop in all of our plants. So in areas where we don't want, direct contact with ammonia on some of the cheese and other areas in the plant, we have these chilled water loops that go throughout our whole facilities. So this left picture here is actually a ammonia plate and frame heat exchanger. So you'd have ammonia on one side and then the chilled water on the other side. These are quite large, and each of our plants has a couple of these to provide the cooling. That really gives the rest of our plant, anywhere from 30 to 40 degree water. We usually use water. Some plants, if you're below the freezing level, you might have a water glycol mix. But in our plants, we're generally just water. We're above that freezing temperature. And so what we do is we send that chilled water out then to one of the first areas it goes is the milk pasteurizer. So we have to pasteurize all of our milk, and actually on the whey side, we pasteurize that also. And what that does is it heats the milk up, kills any bacteria or things that might be in it. Hopefully there is nothing, but it's just a safety precaution. And then we got to cool it back down. So one way we do that is with chilled water. This picture right below it, it shows mozzarella brine bath. So when we're making our mozzarella cheese, the hot cheese goes into these brine baths and actually sits there for about 20 to 24 hours and kind of soaks up some of the brine and gets flavoring and things from that. But we're always adding warm cheese to this brine. So we got to constantly keep the brine cool. And so what we do is we provide chilled water to that. We also have a lot of compressed air in our plants. So when you're compressing the air, it gets hot. That hot air also has moisture in it. And if you send that out to your plants, it can mess with some of the valves and things that might be controlling. So we have to drop the moisture out of the air. And what we do, or how we do that in a lot of our plants, is with chilled water. So it goes through that chilled water loop there, kind of drops the temperature, drops the moisture out. Another area is for oil cooling. So this is air compressor, which we have chilled water going to it to provide the oil cooling. There might be other pumps or motors or fans that would need external cooling. And one of the ways we can do that is with our chilled water loop also. We use a lot of chilled water in our plants. Next slide. And then, of course, once we make the cheese, we have to keep it cold or cool. We do that in large warehouses. These warehouses are very large, and they each have these evaporator coils in them. So just like a small refrigeration system, but these are for very large warehouses. And each one has ammonia lines you can kind of see going to them. And we provide direct ammonia into there, keeps it cool. We also have some instances where we need to freeze the cheese. Maybe we're shipping it overseas or something, or a long ways, or it needs to be chilled for a while. All the cheese would go into these blast freezers, packaged, of course, and then we use ammonia to cool them down and get them real cold with ammonia. So those are some of the ways we use ammonia in our plants. So next slide. So why do we use ammonia? We've actually been using it for, I've been with the company for 10 years, and they've been using it for 20 years before that. It's something we just have used a lot of, and it really comes down to the efficiency and the cost of it, for us anyway. And efficiency and cost can kind of go hand in hand. You get really good heat transfer rates with ammonia, which that requires smaller equipment. Really, it's the less surface area where you're doing that heat transfer. All our plants and areas are already, pressed for space. So if you can keep the equipment smaller, that's a bonus. The smaller equipment also has smaller costs. So the pipes, fittings, things like that. Ammonia, just the cost is fairly cheap. I don't actually buy it, but I do know it's fairly cheap. And then ultimately, I'm the energy engineer for the company, so our electric cost stays very low with ammonia. It's one of the cheapest ways we can keep our plants cool and provide the cooling is with this ammonia. And then more recently, it's all the environmental, and that's kind of why we're here today. So it's got the zero global warming potential. It's got zero ozone depletion. And that's good. We do a lot of reporting now, and we're starting to do more and more of that. So we have to report our scope 1 and 2 emissions. And if we were to, do our cooling with one of these other refrigerants, that would definitely add a lot more to our plate. And but luckily with natural refrigerants, we don't really even have to report those numbers. So in a way, it's kind of future-proof. I think both presenters have kind of touched on that. So we do know we don't really have to do anything with our system, which is nice. Next slide, please. There are cons, of course. It's poisonous to humans. It does smell if there's a leak. It's lighter than air. We haven't had any leaks. And of course, you have sensors and things that will go off. We maintain a very clean, safe ammonia rooms. It reacts with copper, so you got to be careful with some of the pipes or fittings that you might install. Of course, that goes on to training of your mechanics and things. And then it can be hard to manage. So we definitely have a good process safety management program where we have annual inspections, we do audits, we make sure there's the proper signage everywhere. And we just try to be as safe as we can with it. So we've been doing it for 30 years with no issues. So it can be done. Next slide, please. These are some of the safety items or safety precautions we've taken. Anyone who might need to go into our ammonia rooms has to go through our ammonia awareness training program. It's just kind of some paperwork and safety things we go over before we let anyone in. Of course, there's other equipment in there, so you might have a pump in there. Well, you might need someone to get in and service that pump. So they would have to go through the proper training. We also, some of these rooms can be very large. We have, ammonia compressors in there with storage tanks for ammonia and things. And they might be kind of in an area of the plant that, or other people might want to cut through there, well, we don't really let them. We have alternative routes around all ammonia rooms. We keep them locked if needed, and try to only allow the right people in there. And then, of course, we do have SOP training. That's for our maintenance crew. If things go or things break down or whatnot, we need our plants running 24/7. So we do have maintenance guys who can get in there and work on them, and of course they go through all the proper training to make sure they're safe. So next slide, please. All right, now I'm the energy engineer for AgriPeer, and I know this is the most efficient way we can really do our cooling. So I thought I'd talk about some of the projects we've done over the last 10 years to really keep our costs down. And the name of the game in refrigeration is just reducing the lift. That's the difference in your discharge and your suction pressures. One way you can keep your discharge pressures down is with cooling tower capacity. So here we're rejecting the heat to the outside with that cooling tower. And we have had times where our plants grow. We don't have the ability to reject enough heat outside. So we have to add more of these cooling towers, and that really helps keep those pressures down. Keeping coils clean from scale, that's a big issue. Water quality can be a big issue in our plants. We try to keep the cleanest water going to these that we can. And that's all part of a good water management program too, really, in any of the plants. And then we want to float our pressures. So in the summer, temperature and pressure are dependent. So in the summer it gets hot. We want to float our pressures up when it gets hot and then back down when it cools down. On the suction side, this is where you're doing the cooling now in your refrigeration. We want to have low for our freezing. We do freeze some of our cheese, as I said. So we don't want to keep the whole plant at that low temperature if we're only freezing 20% of our cheese that day. We have the higher side for refrigerated sections. So next slide, please. Some other things we like to do is we add variable frequency drives to any motor, pump, or fan that has a varying load. So in the past, these fans and pumps, motors, or compressors would just be on, and they just run at 100% no matter what the load is in your plant. Well, we've went in and retrofitted all of our fans and our ammonia compressors with VFDs, our evaporator fans with VFDs, and condenser fans with VFDs. And we are seeing a lot of savings just in electric costs by doing this. Next slide, please. And then we also, reducing parasitic loads, that can be a big issue in some plants. This can go down to employee training. People leaving doors open, leaking doors, broken strip curtains, or areas where you're overcooling. Those are all very common things we see. We just have to kind of fix them or do some training on them. High-speed doors are great. These doors open real fast. The forklift can go through them and then close them real fast. And you only have the door open for maybe 10, 20 seconds versus a couple minutes where you're just losing that cold air going out to the rest of your building the whole time. Evaporator hot gas defrost. So with our refrigeration coils, whenever you get warm air into the areas, it could there has the potential anyway to have frost on these coils, and so you got to defrost them. Well, you defrost them by adding hot air into it, or hot gas into this coil, which just raises the temperature in the whole freezer. And in the past, this has been done on you might do it once a day just to make sure the coils are clean. We have started testing these sensors that go in, and they only put the hot gas into them to defrost when there's frost. So it might be once a week now versus once a day. And then also heat recovery. Thermosiphon oil cooling is one way. If you're getting a new compressor, it's a pretty cheap add-on you can do. And then look for any pre-cooling. So some of our plants, they all do heating and cooling at different times. So maybe you can take some of the cooling off one area and do some pre-cooling. It's just something to look for. So I think that's all. Next slide. Thank you.
Thank you so much, Mark. And thank you again to all of our awesome speakers. So we have just a couple of minutes left and we're going to go and move on to Q&A. So if you haven't already, please join us over at slido.com with event code #DOE or #DOE to submit and upvote questions. All right, so first question, I'm just going to dive in. And if our panelists want to be able to kind of be on deck to help me answer these, should we hold off on equipment replacements, such as energy efficiency upgrades and electrification with heat pumps, until low GWP refrigerants are ready? And a lot of people upvoted that. So would any of our panelists like to take a stab at that one?
Yeah, I'd be happy to try to take a stab at that. That's a great question, and it's always a balance of when do you replace equipment. I would recommend not doing early replacements, maintaining those systems, and really controlling the leakage is going to be the most important thing. And then there is going to be a lot of changes over the next few years in the market, but it's hard to predict exactly when, you know, very low GWP refrigerant systems will be available, but you just kind of have to keep watching that, keep an eye out on it. I would say over the next, 5 years, we'll see some lower GWP options available for HVAC systems and improving in refrigeration systems as well. I hope that helps.
Yeah, I would just add that, different sectors of the market are in very different places, like Michael said. So HVAC is a totally different animal. Commercial refrigeration, I think, those technologies are ready to deploy and market ready. It's a matter of figuring out the right solution for your facility and whether you want to do a full system replacement or replace components of it with modular solutions over time. There's really no one size fits all.
Thank you. And I think we have time for about one more question. The next question that's also been upvoted many times: can I upgrade refrigerants in existing systems?
I can, or go ahead, Morgan, if you want to.
No, go ahead, Michael. I'll go after you.
I was just for HVAC systems, you can upgrade the refrigerant, but you have to be very careful to make sure you have a compatible refrigerant for your systems and really confer with the manufacturer before doing anything. I would not recommend it unless you have a really good plan and the manufacturer fully supports that and provides training and all the guidance on how to do it.
Yeah, and I would just say, in commercial refrigeration, the retrofittable options where you can continue to use the existing system for the most part they're more of an interim solution. So, many businesses are using them as a way to temporarily reduce GWP while they figure out their plan to go further. But right now, there's in commercial refrigeration, no option that's less than 150 GWP, which is where a lot of the regulations are setting a threshold that can be dropped in. So yes and no.
And one more thing to add, remember, if all of the refrigerant is contained, there's no climate impact. It's only when it's emitted, leaked out of the system, and those leaks can occur if you're evacuating the system and then recharging it with a new refrigerant, there's leakage that it could occur. So just be very careful about, balance that. What is the leakage in your system and what do you think might leak during a change out?
Thank you all so much. And thank you to everyone who submitted questions. I know we only got through a couple of them. I'm going to have to move us on in the interest of time, but we're going to do our best to respond to these questions through our follow-up. I think for now we can go on to the next slide as I just kind of close things up here. So thank you everyone once again, and to our panelists for their insightful responses. This webinar is a part of our 2023 to 24 Better Buildings webinar series. As you can see, we have a great lineup of presentations through March. You can go through the Better Buildings Solutions Center to learn more and register. Next slide, we hope you can join us on February 13th for our next webinar, which is focused on reducing commercial tenant and scope 3 emissions. And you'll be able to join this webinar for the same fantastic experience hearing from Better Buildings leaders and industry experts. Next slide, a shameless plug for our Better Buildings, Better Plants Summit. Registration is now open, and the summit is going to be held in Washington, D.C. from April 2nd through 4th. We would love everyone to join. In addition to engaging in interactive sessions, attendees can look forward to plenty of opportunities to network with their fellow industry peers and experts. So you can check out what the section tracks will be and book your accommodations on the Better Building Solutions Center. Next slide. One more plug for the Better Climate Challenge Roadshow, Cleveland edition. Check out this video series of DOE energy experts visiting several of our Better Buildings and Better Plants partners to see how organizations are putting decarbonization strategies into action. So rock on and tune in to the full series on the Better Building Solutions Center today. If you can't tell, Better Building Solutions Center is where you can find all of our awesome resources. I highly encourage you to check it out. So next slide. With that, I'd like to thank once again our awesome panelists so much for taking the time to be with us today. Feel free to connect or contact our presenters directly with additional questions, or if we couldn't get to your question during the Q&A. I encourage you to follow the Better Buildings Initiative on LinkedIn and X for all the latest news. You can find our handles by their respective icons on the left half of the slide, and you'll receive an email notice when today's recording, slides, and transcript are available on the Better Buildings Solutions Center. With that, thank you everyone, and have a great day.